Hey guys, this is question 11 in section 11.1, and in this question we're gonna go through the following tests. So it can be the F test for a difference among more than two means, and the Levene test of homogeneity of variance. Both of them are ANOVA tests, and then we're gonna end with the multiple comparison for the 2K procedure. All right, and we can answer to the first question without downloading the data, since we have here 6 categories: burger, chicken, and so forth, and the snacks. There are 6. So whenever you choose your null hypothesis, it should be the null hypothesis H0. It can be mu1 equals to all the way to mu6. All right, and the alternative hypothesis is going to be not all of them are equals, and here you're going to end at 6. All right, so it's not 48, and the reason is not 48 because 48 is the number of brands. All right, so they are different brands. Anyway, so we have the two possibilities here. Obviously is not C, because mu1 different than mu2 does not mean all of them different. If we have only one different, that's enough. So this is a particular case of different, and neither is D. So we are either A or B, and we said we're gonna end up to 6. All right, because there are 6 categories here. Do not choose the 48. All right, let's check it. Okay, good. All right, now we want to find the F statistics. So you want to download the data and export it to Excel. All right, so it's already done. So we have the data here, and you can notice here that the data is mixed up. So we have to reorganize it and put it in different fashion in order for our Excel to run the data analysis. All right, so the way to do this is to select the first row, click on the whole row where is the 1 at, and then you're gonna go to the AZ funnel, and then you're gonna put filter on them. All right, so you see here they're all having arrows, and what you want to do is you're gonna go drop down this arrow and you're gonna organize them from A to Z. It should be enough. Okay, so we have all the data rearranged. And what we're gonna do, we're gonna build up a new table. So we're gonna start with the burger, that's the first category. And then we're gonna go to second one is the chicken, and so forth, right? Okay, once you fill up the titles of the table, so what you wanna do is you wanna copy the data of the burger and copy it, and then you want to paste it over here. The best way to not mess up the data, paste it as 1, 2, 3 as value, right? So paste it as value. That's the best choice. And you do the same thing. So you're gonna copy the data from chicken and you move it to the other side, right? Right, select, copy, then paste. Okay, so once you build up your table, what you want to do next is you want to run the ANOVA test. So you're going to go to table of data, and then you're going to select data analysis, and then you're going to scroll all the way up, which is ANOVA single factor. Okay, so here you're going to select the whole table, including the labels, and then you're going to put label check in. This is important. And then the output range, you can put it anywhere you desire. So, okay, so this is our table. And I think now we can go back to the question and look for the F test. So the F that we are looking for is this value in here. So just copy it and paste it over here. And make sure you round it to 2 decimal places. They decided here 2 decimal places, so you're going to be 3.25. So the next digit was 0. Check it. All right, we got it. Now the p-value is just next to it. You can see it right here. Again, copy it, and you want to round it to 3 decimal places. So paste it, and that's going to be 0.0143. So 14. Right. Now you want to make a decision. So your decision is basically you're going to compare the p-value with the 0.05. So if the p-value is smaller, you are rejecting. P-value is smaller than the alpha, which is 0.05, you're going to be rejecting. And this is, in fact, it is, right? So if you write 0.05 into 3 decimal places, that's going to become a 50. 50 and 14 is smaller. All right. So we're going to get reject. And if it is reject, then we're going to go with there is sufficient evidence that the difference between the means is there is a difference in between the means. All right. So we can check it. We got it. All right. So this is the second test that we talk about it, right? So that the first test is done. We did this one already. So right now we are doing the Levene test of homogeneity, right? And the Levene test of homogeneity, this is from your book again, is having exactly the same statement almost. All right. So what it's doing is 80 that sigma 1 squared and equals to sigma 2 squared sigma all the way to sigma 6 squared, and not all the sigma squared are equals, right? And as we said before, it has to be 6. So there is A is the one that matches our hypothesis, right? Okay. So now how can we get the F that? And according to the book, as you can see here on the table, you're gonna take all the values and you're gonna subtract from them the median, and then you take the absolute value. So you're gonna get another table, and that table you're gonna run again the F or ANOVA test. All right. So let's start. All right. So I'm gonna copy this part here. I'm gonna put it right here. Okay. Once I do this, what I want to do, let me go all the way in the bottom, and I'm going to calculate the medians. So I'm going to do it here. So this is the row of the medians, right? And this is really simple, equal sign, and you're going to go to median. There is a function is median. You can click on the tab key. So you're going to open up the function, and then you're going to put the values. Here you can select them and enter. And you see I skipped one, so let me go and get it. Okay, so this is whenever you double click on this, it should cover all the data, right? Okay, so what I'm going to do, again, I'm going to do this. Since the size of the data is not the same, so you have to type it again and again, right? So you're going to be the median. You cannot copy and paste, right? So, and select the data. All right. So once you get all the medians, what you want to do here, you want to do the difference of the value with the median. So to do this, and the absolute value, of course, all right? So let me go back to the book again. You see here we are doing the values minus the median absolute value, and those are the new values, right? So we're going to do it in one step. So this is going to be equal sign, all right, absolute ABS, that the absolute value. You're going to open a parentheses, and then you're going to put the two values. So the first value should be the first value on the list, minus, and it should be the median here. And then you have to lock the median because you're going to drag it down, right? So I'm going to have to do F4 in my computer. It might be something different in your computer. If you have any problem, you can always type a $sign before the letter and type a $sign before the number. Close it and you're all set. So this value here, you're gonna drag it and you're gonna move it all the way at same level of the last one, and those are all the values. Now I'm gonna repeat the same process with the remaining columns. All right, let me do it one more time. Here you're gonna be equal sign absolute value ABS, open a parenthesis. Now I'm gonna select the first value in the chicken, minus sign, and then I'm gonna select the median, corresponding median, and then I have to lock it with F4 or by typing a $sign before the letter and $sign before the number. Close the parentheses and enter, then drag it down. As many cells you have under chicken, so up to here. All right, you can double check whether you missed something or not by double clicking on this, and you can see those are the two cells involved. All right, okay, so I'm gonna keep doing the work here. Okay, so once you have the table all set, what you want to do, you want to go to data table here, and then you're going to go to data analysis and you run the ANOVA test one factor again one more time. So you're going to select the whole table here, then make sure the label are selected and make sure here you are selecting a cell different than the other one, previous test. Okay, you run the test and this is our table. So now we can go back to the question and input the data. So here they are asking for the F value, so you can copy it, then you paste it here, and then you want to run to 2 decimal places, so 635, so that's going to be 4 instead of 3, and check. Good. Then they are asking for the p-value, that's the value next to it. Copy, paste, and you want to round it to 3 decimal places. So you're going to be 1716, so that's going to be 172. And check it. Be good. All right, so now we're going to compare 172 0.172 to 0.05, and obviously this is bigger. So every time the p-value is greater than the alpha value, then you do not reject. Do not reject the 80. All right. And here, if we don't reject, every time you can't reject, it means you didn't have any evidence. It means not sufficient, right? Insufficient evidence. All right. Check. Good. All right, so question C is about why we are doing this homogeneity test, the Levene test of homogeneity. All right, so this is again from your book. So you can see here clearly that one of the conditions for the one-way ANOVA, all right, is the homogeneity, all right, of the variance. What does mean homogeneity? So we want the sigma 1 squared equals to sigma 2 squared, and so forth, how many we have. And this is typically is 80. So we want do not reject 80 for this test. So this is a must, or you must have it before doing the F test, all right, the first test. And this, if it happened that 80 we do not reject, if we did not reject 80, then our prior test, which is the ANOVA test, F test, was valid. And if we do reject this homogeneity test, then the prior test, the previous test that we did in the first question, it is not as valid. So it's question of validity of the first ANOVA test. And here the statement is, you can see it here. So here is saying that the amount of variability, right, in cells, the homogeneity of variance assumption has not been violated. All right. So we need to check the homogeneity, whether it's valid or not. All right. And if it is, we did not reject, then our prior test, what we did in the first part, was valid. So here it makes the result in part A less reliable or not. And actually we do not reject it, right? We did not reject. So there is a homogeneity. So this makes our result more valid, not less valid. All right. So B, the only choice that has a more valid. All right. And we're going to go with B.